What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 5.1, angles of triangles. So we'll be able to classify triangles by sides and angles, and then also find the interior and exterior angle measurements of those triangles. The first thing we want to know are all the types of triangles. So what we're going to do first is look at classifying triangles by their sides and then by their angles. A scalene triangle just means there are no congruent sides. Isosceles have two congruent sides. One way I like to think about is isosceles kind of starts like isolated. So there's one side that's isolated. And then an equilateral triangle just means three sides are equal or three congruent sides. The triangles that are classified by angles, we have acute triangles. That just means all three angles are acute. Right triangle means one is right. An obtuse triangle means one is obtuse. An equilateral or an equiangular triangle is always tough for me to say. Those are just three congruent angles, so that means they're all equal to 60 degrees. Okay. Equiangular are also considered acute triangles just because all three of their angles are less than 90 degrees. So what we're going to do here is we're going to classify this triangle by its sides and determine whether it's a right triangle. Now, the tricky thing about this is we do not know the length of the sides, so we're going to have to use something called the distance formula. So what we would want to do is maybe start with the segment OP. And OP has 0, 0 and -1, 2. So that's going to connect from here to here. So if we want to do x2 minus x1, first we want to name our points. So I have -1 minus 0 squared plus 2 minus 0 squared. And then I'm going to find the square root of that. -1 minus 0 is -1, and -1 squared is 1. 2 minus 0 is 2. 2 squared is 4. So I'm finding the square root of 1 plus 4, which is the square root of 5. And that's going to be about 2.2 or so. What I really can do here, though, is just continue to keep it in square root format. I'm not going to necessarily sit here and calculate it because it's going to be able to determine what my lengths of my sides are based on the distance of those. Okay. I'm going to do that same thing with point PQ. So PQ has -1, 2, and Q has 6, 3. And then I'm going to label x1, y1, x2, y2. I'm going to do x2 minus x1. That is 6 minus -1 squared plus 3 minus 2 squared. 6 minus -1 is 7. 7 squared is 49. 3 minus 2 is 1. 1 squared is 1. So the square root of 49, which is the square root of 50 for PQ. So far, it looks like I don't have any matching sides. I would do that same thing for the segment QO, and that is 6, 3 and 0, 0. So I'm going to do, maybe say that these are my x2, y2 since they're bigger, and these are my x1s, y1s. So 6 minus 0 squared plus 3 minus 0 squared, square root of that. 6 minus 0 is 6, 6 squared is 36, 3 minus 0 is 3, 3 squared is 9, 36 plus 9 is 45. So I'm trying to find the square root of 45 for this one. And if you notice, they all have different sides. So since they're all different, we can classify this as scalene. The one thing I do need to see is I determined if it was a scalene, isosceles, or equilateral. Now I got to determine if it's a right triangle. And how I do that is I look at what angle looks like a right angle, and then I figure out, is it showing a perpendicular slope? So what I maybe would do is find the slope from P to O, and then find the slope from O to Q. And I can also find the slope from P to Q and just see if they have any slopes that are going to show that perpendicular relationship. So I'm going to actually erase this right here. Hopefully you didn't need it. If you need it again, you can just rewind. But what I would do is I would find the PO slope first. So that is your change in y over your change in x. So I did 2 minus 0 over negative 1 minus 0. So that is going to be 2 over negative 1, which is just negative 2. My OQ slope, we'll do that in green to sort of match that. Again, change in y over change in x. 3 minus 0 is my y. 6 minus 0 is my x. This is going to reduce to 1/2. So right now it looks like PO and OQ are perpendicular because they have opposite reciprocal slopes. And just for the sake of making sure we're getting everything clear, PQ, I would do change in y's. 3 minus 2 is 1 over change in x. 6 minus negative 1 is 7. So this is not going to be perpendicular. So my right angle, meaning they're perpendicular, is at point O. Okay, and that just means this slope and this slope are showing perpendicular slopes. Okay, so the next thing we're going to talk about are triangle sum theorems and the exterior angle theorem. A triangle sum theorem is just going to state that the measure of the interior angles is equal to 180 degrees. So if I added the angle A plus angle B plus angle C, it should be equal to 180. And then the exterior angle theorem, that's on the back page of your notes, just means if I want to find the measure of angle 1, I can add A's angle and B's angle together, and that'll give me the measurement of the exterior angle that's non-adjacent, meaning not next to. A lot of the times I'll have you find the exterior angle and then draw a line to separate it from the two opposite angles. Okay, so that way we're kind of setting like this side of the equation is equal to this side of the equation. All right, so what we're going to do is we're going to find the measure of JKM. So JKM is this exterior angle. So what I do is I label this as exterior, which means this, the two non-adjacents are equal when you add them. So what I want you to think about this is one side of the equation and this is the other, and they're going to be equal to one another. So all I would do is write 70 plus x is equal to 2x minus 5. Okay, and all we're going to do is first we have to find whatever x is equal to and then start to solve. So I'm going to first move my x's to one side. It might be best to move the smallest x first. That way I don't have to deal with any negative exponent or any negative variables. 2x minus x is just going to give me x minus 5, and on the left side I still have 70, but if I'm adding 5 to both sides, x is equal to 75. Okay, so if x is equal to 75, then that means I would have enough information to plug this in and go from there. Okay, so JKLM says 2 times x minus 5. That just means 2 times 75 minus 5. I know 2 times 75 is 150. 150 minus 5 is 145. Okay. The next thing we have going up is what we call a corollary to a theorem. My bad. We are struggling with words today. That is when we have a statement that can be proved easily using a theorem. So we can prove this statement by using the right angles theorem. So we can say that the measure of angle A plus the measure of angle B is equal to 90 degrees because we already have 90 degrees here. So that means these two have to be split with the other 90 degrees because all angles of a triangle, A plus B plus C, are equal to 180. So this is the corollary of that theorem. Okay. So when we want to solve for each one of these, what we're going to do is try to use those corollary theorems to solve for them and then determine what each angle is. Let's go ahead and start with this one. I know that I have my exterior angle shown, so I'm going to draw my line. Here's my exterior, and I know that 40 plus 3x is equal to 5x minus 10. The first thing I need to do is go ahead and solve for x, which will help me then solve for angle 1. Subtract the smallest variable first, add your constant to the other side. These cancel out, so I get 50 is equal to 8x. right? No, I should be subtracting it. Subtracting, that's going to equal 2x. Okay. Now I divide by 2. X is equal to 25. Okay. If x is equal to 25, this is 40. 3x would be 3 times 25. So this is 75. So right now I have 40 plus 75 plus angle 1 is equal to 180. So what I probably should do is figure out what the leftover is. 40 plus 75 is going to give me 115. We'll call that a missing angle x is equal to 180 minus 115 from both sides. X is equal to 65. This is just one way you can solve for the angle. I realize that you could also think about this 5x minus 10, that's 5 times 25. So that is 125 minus 10, which is also 115. And then the supplement of 115 could be 65 because they're making a straight line. Okay, so that's one way you can do it. This last one talks about what was stated previously, and it just says the acute angles of a right triangle are complementary, which just means if I have 2x and the x minus 6, that is going to be equal to 90 degrees, because if this is 90 degrees and this is 90 degrees, together they make their 180 degrees. 2x plus x gives me 3x. Now I have this, 3x minus 6 is equal to 90. Add 6 to both sides. 3x is equal to 96, so that means x is equal to 32. Okay, to find the measurement of each angle, then I'm just going to plug that right back in to where I have my x's. 2 times 32 will give me the measurement of one angle, and 32 minus 6 will give me the measurement of the other. 2 times 32 is 64, and 32 minus 6 is 26. Just to prove your theorem, you can take 64 plus 26 plus 90, and it does equal 180. That is going to conclude our notes today on 5.1 angles of triangles. Thanks so much for tuning in. Give this video a thumbs up if it helped you at all, and I hope to keep you